I would like to welcome everyone today to the Irvine Micropreneur Program. We have a presentation today on emerging technology that is going to be presented by Joe Tavormina, who's the president of Tav Networks. Joe is going to discuss smart networks, which are networks of communication that are able to make decisions and process information in ways that are really new to our culture. Joe, I'd like to welcome you today. Are you there, Joe?
Yes. Hello, Robert. Thank you.
Okay. And I'm going to go ahead and turn the presentation over to Joe. Joe, welcome. You have the floor.
All right. Well, thank you, everyone. Thank you for participating in this and giving me the opportunity to speak on a subject. Let me start by just saying that Tav Networks is a new company. We formerly have been operating under Tavormina and Associates, and we now created a new corporation to move our focus on smart network technologies into that entity. So hopefully you hear more about us in the future. Most of the recent work that we have done in our company is in the energy sector, and we've been working with the smart meter application, and in particular with PG&E, and a smart meter is shown on the cover slide there on the left. Prior work, we've done quite a bit of work in the past with sensors and communication applications, and as you'll see, that's kind of what this presentation is about. So let me go to the agenda for now. What we hope to accomplish in the next 30, 40 minutes is to discuss what is a smart network and give some examples and talk about how they're going to change our lives. And then I want to introduce some of the issues that smart meters are going to cause and some of the controversies, and then end up on the business opportunities that we will see in this area of technology. Okay, so what is a smart network? Smart network is a term that we're using to represent applications where machines are talking to other machines over a network, and typically this would be a network of sensors that are collecting data and reporting that data back to a central repository somewhere. And at times, a smart network may also include a central controller that's issuing commands to remote actuators. And so this is, in my view, the most common thing we see when we refer to a smart network, and we're using that term to describe such a network. What's new about this type of situation is that there are very few human beings involved and no direct involvement by human beings. And most of the network protocols, security processes that have been developed to date have been done with the human being in mind, sitting at a console somewhere and interacting with another human being on the other end, or at least one human being interacting with a machine. Here we are talking about machines interacting with machines. So in a smart network, there's really no human beings to type in passwords to authenticate themselves and to be personally responsible for the password. There's no authentication based on what your mother's maiden name is, and that creates new issues. So this introduces a number of challenges and opportunities that we're going to get to. What I want to do next is share some of the smart meter applications that I'm aware of across a number of industries listed on the slide there. And these are ones that I have some familiarity with. Maybe some of you will share later some of your familiarity with such networks. So let me go to the utilities and energy management sector. This is where our staff has spent the last 3 or 4 years with a significant amount of effort at Pacific Gas and Electric Company, and for short, just refer to them as PG&E. PG&E has deployed 10 million network devices, remote devices, smart meters, 6 million electric meters, and 4 million gas meters that now report the data that they collect several times per day. 10 million nodes is a huge network. There's very few instances I can think of networks that are that large. And so just the sheer scale of such a network requires a lot of automation and a minimum of human interaction. Now, the whole smart meter idea is motivated by the idea of demand and response. So in the utility industry, Utilities intend to charge us more for our electricity during a peak period, let's say a hot summer afternoon. And in places like Southern California and Southern Nevada, about 30% of the electric load is associated with air conditioning on a hot day. If they price the electricity 3 to 4 times as much as the average during those periods, the hope and the economists assure us that we will all respond by controlling when we consume electricity. We'll cool our buildings and houses earlier or later in the day and thereby avoid the necessity to build new power plants to manage the peak load. So that's a lot of what's behind this whole smart meter movement. But the networks that are being put in place, the smart network in this case, it's referred to as the automated metering infrastructure network in the utility business. That also serves distributed energy generation and also some of the issues that we'll discuss with electric vehicles. So the network is more than just to collect meter information. It's also going to be used to manage when electric vehicles are charged, for instance, or to manage how a solar panel is connected or disconnected for, say, safety reasons to the grid. Let me go on to the next slide. So the whole idea of the AMI network is that the hourly usage data will be available for a customer to look at the day after. And so as a PG&E customer, this is possible as we speak now. One can log on to the portal and see what their energy usage was hour by hour for the previous day. And then knowing what the price of electricity is this day, we could make decisions about how to turn off our air conditioner, set the thermostat higher, that sort of thing. Now, I actually believe that new IT infrastructure is going to be needed to fulfill the promises of the automated consumer energy management. I don't think that we're going to care that much about saving 10% of a $50 a month electric bill. And I believe that new machines and new networks need to be put into place. Applications need to be developed that will manage that for us. And we'll build a profile on some web portal, and then that will determine when the thermostat goes up or down in temperature setting, that sort of thing, when we turn off the heat pump. But let me also mention that electric vehicles are, depending on what you believe, electric vehicles are going to be introduced en masse. The major automobile manufacturers are anticipating, we're kind of in an early adopter stage now, and the major manufacturers anticipate a large uptake of EVs in 3 to 4 years, and a maturing market in the 6 to 7 year time frame. EVs actually can double the amount of demand for energy delivered by the electric grid. And in a place like San Francisco with the moderate climate, one EV is more than equivalent to one household in terms of energy consumption, just simply charging the car. And you can kind of think about what a typical gas bill is for fuel for your automobile per month, versus what a typical electric bill is. And if you more or less equate the cost, you can see that driving the car around actually consumes quite a bit of electricity. Well, the point of the grid is that you really don't want the cars to be charged at the same peak period when electricity is in high demand and when the transformers are being taxed. So the AMI networks and the smart networks in the utility business will be used to control when EVs get charged, typically during off-peak periods. One other interesting aspect of EVs is that public charging stations will need to become ubiquitous. And if I pull up to a shopping center and charge my electric vehicle, the question is how the network will associate that charging and that consumption with my personal electric bill. When you begin to think about that, that's quite a challenge, and there's a lot of moving parts to that. So that's another example of a smart network requirement in the near future. I'm going to move on now to some of the transportation industry applications that I have familiarity with. In the railway business, some of the rail carriers are moving to smart cards enabled with RFID tags in the card itself. This provides a whole new level of capability. And let me pause and just say that the way RFID tags work is there's no battery involved, but there is a small integrated circuit that's got a radio receiver and transmitter, and then the card itself includes a small antenna. And the idea is that the antenna picks up energy from a transmitter in the RFID reader that activates the IC, and then the IC sends back a few bits of information, which essentially amounts to a serial number, a unique serial number, associated with that particular RFID chip and that ticket or that card. So simply by posing the question of who hit it and then feeding back a serial number, there's all sorts of applications that can be enabled, and especially in this instance, the ticketing and the recording of a passenger using public transportation. But think about that for a minute. Compared to the past, we would now be able to tell where that passenger is, at what portal he just walked through, whether he's in the train or on the stand. We can tell the timing of when customers and passengers move from one location to another. We can tell about the congestion and the speed of transit. And in the future, if you look at the turnstiles, there's going to be the ability to use smartphones to do ticketless ticketing as well. Another example from the transportation industry that's well in use now is the container shipment tracking. There's a photograph of the large containers used on cargo ships, and there are a number of devices available in the market now that look at the tamper-proof seals for those containers. Some have sensors that detect malicious content or contraband content in the container, and this is then sent back to the network using readers. This technology is different than the RFID technology used in the ticket. It's a longer-range technology that does require a battery at present. But this is being used today, and the RFID and smart network ensures it actually tracks the container and also ensures the integrity of the contents of these containers. So I'm going to move on now to some of the supply chain applications. Walmart has been an early adopter of the RFID technology used in supply chain management. There's some examples on the top right in the slides of the types of tags being used on boxes, cardboard boxes typically. And you can see there the antenna pattern plus the little place where the RFID chip is installed on that antenna. And these RFID tags are being used to replace barcodes. And the reason they're better than barcodes is you do not need a visual line of sight to make a read. In volume, these tags are already under 5 cents per tag, so the cost is moderate for the typical value of the contents of a box. And so this is being used today in warehouses and kind of through the logistics and supply chain to track the location of a box and where it is on a shelf, that sort of thing. A variant of these tags are being used inside of cabinets, and in fact, our folks in my company have an opportunity now to work on a medical cabinet application, crash cart in a hospital, and the issue there is to make sure that the crash cart has the contents needed for the emergency room doctor before they open the drawer and go looking for stuff. So let's go to the food and drug slide. For about 10 years now, cattle that we consume as food have been tracked from birth to the slaughter time using radio tags. And this has proven to be useful to incentivize farmers and people that raise cattle because the quality of that cattle in the slaughterhouse, people actually get paid incentives based on the pedigree and the quality. And so by being able to track the cattle through its lifetime, we can associate that with the growers and the feed and all the things that happen along the way. In the drug business, near-field tags are being used to protect against counterfeit drugs being put into the supply chain. We've all heard of some of the incidents of drugs being illegally put into the supply chain, and they might have the wrong dosage level or problems with the drug. And so by tracking vials or by tracking stock, through the supply chain, we can again know that is a valid stock that came from the right place. There's a photograph on the bottom left of a very small RFID tag that is used for implantation. I'm not sure I want one of those myself yet, but people with better imagination than me can think of things where the implanted RFID tag would be useful. I'm going to move to some of the consumer retail applications. Over the last few years, RF tags have been used in the apparel industry to track individual combinations of style, size, and color, so that at the store shelf, a clerk can tell what's in stock and what's out of stock, which I think is quite useful. And in various places, RF tags are being used at the shelf. Here's a photograph from the UK where somebody with a cell phone that has an RFID reader can see what that particular item is and get some immediate feedback on a sale price or competitive prices or stock simply by waving their handheld device right by the tag. And that kind of brings me to what's happening in the near future in the banking and financial business. Very interesting is that cell phone manufacturers are already trialing and are very committed to introducing RFID readers into handheld devices, our cell phones. And this is being named near-field technology, or NFC. It's an acronym that they're using for that. And once the reader is in our cell phone, then our cell phone can be used to interact in a whole variety of ways with ATM machines, with ticket counters, in a classroom to take attendance, just an endless variety of new applications. But when I think about this, I think of all the things that can go wrong with the technology. What if someone steals my cell phone? Can they impersonate me? Or maybe I've got to put a code on a cell phone to turn it on and activate this feature before it can be used. I'm not sure. But that's what's coming into our future. And so those are the applications that I have some familiarity with. And I'm going to move on now to kind of my list of issues. So when I think about these things and given my experiences, I think the fact that we have smart networks where no human beings are involved, it creates the need for substitution of certain functions that are present in our current networks where we have human beings. So the first thing I have on the list is a connection, a basic connection. I know that for me, when I travel around using my cell phone, my mobile phone, I get dropped more often than I really like. And when I'm dropped, I personally redial and I can reestablish a connection. But if that connection is associated with a sensor that's in a fixed location and the call gets dropped, well, what do you do then? How does the sensor deal with that? And in our work with PG&E and the smart meters, we've seen problems as we get down. It works well for 90-95% of the deployment, but as we get down to the last few percent of deployment, we end up with the problem meters where connection is a basic issue. A second issue is authentication. I mentioned that already, but substitute for personal passwords and secret information if needed. Third issue is certification. When we go on the web now and we we are talking with a bona fide website, a security certificate is presented by the website, and I can personally review it and make sure that I'm satisfied that this is the real thing, and I can move on. But how will certifications be handled when it's a machine talking to a machine? That's an unsolved problem. Privacy is becoming a big issue. How do we protect against indiscriminate use of information? Some of the people receiving smart meters are concerned that their neighbors will know, or a thief might know, that they're not present at home, and then their house would be subject to theft. There's other kinds of loss of privacy as well. It turns out that Canada really has a pretty good privacy policy. In the U.S. here, we're still developing that. A fifth issue is data management. A lot of detailed data comes from the many nodes associated with these networks. In order for a human being to see the data in summary and make sense of it, some automated consumption and automated presentations of data are needed. This is still an evolving field. So those are the things that I think of when we talk about substituting for human interaction. There's some additional technical challenges. A typical sensor, if you think of an RFID tag, it really has a very, very small processor capability. And that small processor means that encryption is not possible using the types of encryption we use in our laptop computer. So new strategies are needed there. And then a device that's operating on a battery, well, the battery needs to last a long time. I know in the utility business, the desire to have water meters and gas meters have a lifetime of 20 years on a single battery that's included. And then to conserve the battery life, these devices need to go in a sleep mode for most of their lifetime, like 99% of the time or better. And when you're in sleep mode, that means you're not listening. And so strategies are needed to time things and synchronize communications. So that's my list of issues. I'm going to go now to the controversies that we've seen in our work. Surprisingly, one controversy that comes up time and again is the worries about being exposed to RF energy. And for something like a smart meter, it's a device that's on the side of a residence or the side of a building, far away from my body. But people still have concerns on how much radiation they're being exposed to. Data privacy, I mentioned that already. That's a concern and a real concern. There's concern by our government about protecting critical infrastructure. So the electric grid, the communications grid, those are deemed to be critical infrastructure for our economy and livelihood. And the government is taking a position on some minimum requirements to keep these public networks operational during a time of crisis. Another question that comes up in the utility business is whether the utility should ask us to pay them to capitalize a whole new network, or whether they should use existing public networks that are in place. And one of the issues with, say, the cell phone network is that during a hurricane, it often will fail. So that's an ongoing debate of what the best way to go is and whether it's worth capitalizing additional networks. And then a final issue I'll bring up is interoperability. There are standards such as the ZTE radio standard, but just because there's a standard does not mean that the device from one manufacturer will work with the device from another manufacturer. So that's an ongoing issue, and I'll leave it at that. Okay, let me move here to the business opportunities that we see. This is not a comprehensive list, but the first issue is the one that we're addressing in our work with utilities are just providing coverage for the last 5% of the sensors. I think upcoming, there's a number of issues in how smart networks, machine-to-machine networks, use certification, authentication, and security. This is still being invented. Data privacy needs to be, first the policy needs to be developed, and then means to enforce those policies automatically are also needed. I mentioned data reduction, distribution, and presentation. Nobody wants to look at the data from 10 million devices, raw data. I see that there's going to be quite a need in the future for consultative services, simply to put systems in place and to make them work, and then to repair them when something breaks. That's been a mainstay of our business for the last several years. And finally, I wish that I was more creative, but a lot of application development needs to be done. And I think a lot of this, I predict a lot of this will center around smartphone apps. But I think independent of that, there'll be other venues and other vehicles for delivery of applications. So I'm going to wrap up here my monologue. My contact information is shown on the last page. And again, my name is Joe Tavormina. But let me pause here and take questions or receive comments. Let me start by asking if any of you would like to share your view of some of the smart network apps that you've seen that maybe I didn't mention.
Yeah, I'd like to speak up if I may, Joe. The thing with smart networks, I've heard in the public forums more protests than I've heard people talking about the opportunities or benefits of smart networks. What are your feelings around that? It seems like the smart networks have thus far gotten poor public relations. Do you agree with that?
Well, I view that, and if you're talking about in the utility space, and in particular about the smart meter protest, it's a vocal minority inspired by, I think, a press that doesn't have enough news. So when there's protest, it becomes newsworthy. And, right now at PG&E, a couple months ago, I know PG&E and the California Public Utility Commission finally threw in a towel and said, okay, we will let customers of the utility opt out of the smart meter, and we'll put back the old meter with the spinning wheel. And if you want to do that, the charge is it's something under $100 to return to the old days, and then maybe $10 to $15 per month is a typical kind of fee. So I think there's been to date less than 1%, well under 1% of the clients that have decided to do that. It's actually less than 0.1%, I think about it, on the order of a couple of tenths of a percent. So I think that there's been a lot more vocal publicity about that than reality.
So your feeling is that you feel that it's blown up a little bit over how large the controversy actually is?
I think so, but let me also say this. I think that in the public utility space, the monopolistic utilities are not used to dealing with the public, and they don't have a particularly effective market communications outreach. So I think the large utilities can do a much better job of explaining things and I'm not saying placating people, but it's really explaining things. Some of the small municipals, like in Austin, Texas, the municipal utility there, they did a very good job of explaining to folks their program and what it amounted to. And I think part of the problem of the large investor-owned utilities is that people just generally are angry about being monopolized by utility. So that's some of the.
I see. I note, I'm looking out in the audience, I recognize a couple of the names. A couple of the folks are technically oriented. Mark Hagerman, is your microphone on?
It is now.
Hi, Mark. Do you have any comments? I have mentioned, Joe, you've heard of Mark before. Do you have any comments or any questions or anything to say with respect to this, Mark?
Not yet. I'm still, after a discussion a month ago as I was doing some research, it's a lot easier to find comments and protests than it is to find any actual data on, why or how or anything else. So almost everybody that I've talked to is going, oh yeah, I'm going to go out and shoot it with a shotgun or something, or call PG&E, and everything from one guy was wrapping his with aluminum foil because satellites could affect it or something. Remind me of the crazy days.
Wow. What? Yes, I hadn't heard that. I'm sure you're thrilled to hear that, huh, Joe? well,
I feel compelled to give at least one counterexample. So in our work at PG&E, one of the large clients is Paramount Farms, which I think has, about 200 sites spread around the Central Valley. But they were very anxious to have their smart meter data so that they could manage their usage and control their bill, to the point where the utility went out of its way to accelerate the availability of that data for them. But Mark, I understand what you're saying too. We've seen a lot of that as well.
And I see that Hank was, I'm sorry, Mark, were you finished talking?
Well, I was going to make one comment. When I was down in the Salinas area working for the county, that the farmers there would have multiple pumping stations. And they had meters at each station, so they had to pay somebody to drive around. And they had a meter for the PG&E as well as a meter for how much water they'd actually flowed. And so they would, have this guy drive around in his pickup truck to all these different fields and collect all of this data. So I can see in this kind of case, they had a direct correlation, but they could tell when pumps were wearing out, pipes were plugged and everything by power would go up, water flow would go down. So I can see for some of the institutions, this is virtually a free thing, that they can now collect data that they've actually always wanted. But, was it going to be cost effective to collect in, a way of cost versus, the information? So I can see where there's applications where this would go. The majority of the people, it's, got one guy that's in the fire department up here that he's got a 700 square foot house, and his bill went up from $35 a month to $150 a month, and he's going, what's happening? So, PG&E's been out and replaced the meter twice, and then he's also an amateur radio operator, and he talks all night on the 10 meter band, so he's probably pounding his meter to death with, high RF. But
Mark, on that instance, I think Robert mentioned this to me, but one possibility is that the old analog meters actually wear out, and when they wear out, one of the failure modes is they just start recording only half of the electric usage, because it's basically looking at both sides of a transformer, and so unfortunately. Sometimes just replacing a meter that's broken, and in the old days nobody knew it was broken because it was an analog meter with no backup. Just simply replacing with any good meter would cause the bill to go up for some of the clients.
Well, was there any program, do you know of, Joe, that PG&E would go? You said that power-wise, the batteries and stuff could run for 20 years. And I'm assuming that it could actually tap in the line if line was available so they could keep it going. But was there an actual life expectancy on the analog meters? Were they good for 10 or 15 years? Because, moving parts, I don't care, unless they're all jeweled, they're going to wear out or, create drag or do something.
Joe, you still there? Did we lose Joe? Your microphone is muted.
Okay, here, I just unmuted it. Sorry about that. Yeah, so Mark, I don't know much about the old analog meters. There are folks that do, but I'm not one of them.
I'd like to, if I may, Hank Levin has had his hand raised for a few minutes. I don't mind going back to this, but I also want Hank to have an opportunity to ask his question, if that's okay.
I'm finished anyway, thank you.
Okay. Hank, are you there?
Yeah, can you hear me?
Yes, we can.
Okay. Yeah, I have a tri-field meter that I have used around the house to check my monitors and TV screens and stuff like that, and it's been very informative for me. Also checking cell phones, use it to choose the cell phone that I have. But my next door neighbor got a smart meter, and I went out there and checked it. It didn't seem to have nearly the EMFs or radio output that a lot of the gadgets around my house, including my electrical box, has. Has anybody tried to just go out and just show people on a meter like that, compare the smart meter to, say, their television set?
I'm sorry, I lost the question. I was following the conversation, but what was the question?
Has anyone thought of going out to people's houses that have complaints and showing them on a meter, an EMF meter, or a radio measuring device?
Okay, yes, I understand. So we've actually thought of that as consultants to PG&E. One of the problems, though, is that being the monopolistic, utility, the only place you can buy electricity, is that people who are already suspicious of them or angry with them don't believe anything that they have to say. And so, PG&E has commissioned, RF safety studies and done various things, but every time they go and meet with one of their angry customers, then nothing that they say is believed. So it would have to be, I don't know, maybe if some other party was able to do that, maybe there was, but even then, if it was like, maybe if the U.S. government went and measured this, maybe then there'd be some believability, but then again, maybe not.
It's interesting to me that the conversation is centering almost exclusively around the utility and PG&E aspects when the smart networks covers an enormous territory. And Joe, I just find that interesting myself. That's what people kind of glommed on is the utility PG&E smart meter space, where we're talking RFID and cell phones. We're talking some incredible benefits and some potential real risks relative to personal security and privacy and government security. It's just interesting to me that the conversation is centering primarily on the utility space. Would someone else like to make a comment or ask Joe a question? Anything you'd like to speak up about?
Hi, Rob. It's Gene.
Hi, Gene.
Having worked in IT and knowing the power of computers to grab and maintain and store data for long periods of time, like it never disappears. The utilities has been something that's been a lot in the headlines of late, but the ramifications of this kind of data gathering capability, quite frankly, scares me. Who's got the data and who do we trust with this stuff? Because if everybody's carrying around an RF chip card, every movement that you make is tracked everywhere that you go from that time forward.
I couldn't agree more. Aside from, I live a pretty clean life, so I guess I don't worry all that much about being tracked. But when I start doing financial transactions on a cell phone, and given the already existing level of credit card fraud and identity theft. I wonder where that's going to go.
Well, and I suppose anything is possible. And the thing is when you bring online the conversation about not just the people that are supposed to have the data having access to it, but good God, imagining someone hacking some of these networks. People are worried about their credit card data being stolen, but this is 10 times more data than that conceivably being distributed across these networks. And at the same time, it's something that absolutely is coming. Thoughts or comments, Joe?
I wish I had answers, but I don't. I share the concern, and I guess the good news is that since we're in this business, I guess there should be some opportunities coming up.
Yes. Well, and there will be. This is a huge growth arena, and for people that are technically oriented, there are incredible opportunities. You know, Gene, one way to respond to these kinds of issues is to actually have a product or service that helps to ensure protection or privacy, and there will be companies coming out with that. There are niches. There are probably dozens, if not hundreds, of niches that people could fill, addressing the very kinds of concerns that we're raising today with respect to smart networks. So it is an area of tremendous opportunity. Well, good. So would someone else like to make a comment or ask Joe a question? Okay. I'm going to talk. Did someone just speak up there?
Yeah, this is Mark Hagerman again. A question for Joe. How is the data transmitted from the smart meter? Is it going on like Powerline Carrier, or do they have, like my water district has little node gizmos around that when interrogated, my water meter, splurts out a little data burst, and the guy driving around the truck can read my meter.
Yeah, so the ones I'm familiar with, several of the different vendors' products. The vendor that was used by PG&E for the electric meters is Silver Spring Networks, and the vendor that was used for gas meters by PG&E is Aclara. And those are two different systems that work in two different ways, which I can quickly describe. Other vendors that have a good stake in this in the utility field include Itron, include Census, and then there's a Badger meter for water meters. And so generally speaking, the electric meters have the advantage that they are on the line, and so they can draw power from the utility side of the power distribution grid, whereas the water meters and gas meters typically do not have any power, so they're the ones that have to work on a battery that lasts for 20 years. In the electric meters, most of the vendors have chosen to build a transmitter that works in the 900 megahertz ISM band. That's actually 902 to 928 megahertz, and it's the same frequency band as that is used by the original cordless phones used 900 megahertz. I guess it was second generation that used that. And I'm trying to think of what else is there. But anyway, that's a very common 902 to 928 ISM band. And these electric meters typically burst the data out just a few times a day, 4 times a day is typical. So most of the time, they're not transmitting. They are receiving because there's a chance that somebody back at headquarters is polling it and saying, give me your data now. But just on a regular basis, they're typically storing up the data and then transmitting it. And they have the ability, if a connection is lost, they'll store data for 30 or 90 days, depending on whether you're recording by the hour or by every 15 minutes. And so eventually the data will get through. On the water meter and gas meter side, because those devices have to work in sleep mode and preserve battery life, the system by Clara at least, and I think the other systems as well, they wake up every so often, 2 or 3 times a day, and they burst out the reading that they have at that time, and then they go back to sleep. And so it's a one-way communication system. So that's what I know, and I'd be happy to go into more detail with you offline.
Okay. Also, just one final little piece or a quick answer question. So they actually have to install an entire repeater network so that it can, all this data that's being bursted out can get back to whatever central location?
Yes. So there's one network that has been installed for the electric system, and that's a mesh network, and a second network that's been installed for the gas collection system, and that's a star network. And that's very typical of most of the utilities that are doing this. There's also some utilities, but not many, have chosen to use meters based on the cellular network. So in that case, they put a little cellular radio, much like our cell phone, inside the meter. But most of them have decided to capitalize new networks for this.
Okay, thank you.
Great. So I'm going to take a moment and talk about next week's presentation, and then we'll do any last-minute wrap-up. So next week I'm going to do the presentation. It's called Making Progress with Your Small Business in a Difficult Economy. And we continue to hear that the economy is challenging for a lot of small businesses. I've noticed around town that some traditional businesses like restaurants and things like that are particularly having a tough time. So the presentation next week is going to emphasize for a small company, what do you do in an environment like this? And in particular, the idea is to have, although we don't normally like to put quick fixes into companies, there are steps that can be taken that work fast and that can turn things around quickly and start to get something that's having a tough time moving in the right direction. So I'll be presenting that next week. Those of you associated with small businesses, I would welcome your attendance next week the same time at noon. So I will check one more time for any other questions for Joe. Okay, very interesting presentation, Joe. It's an area of opportunity and challenge, and I find it very interesting how the world continues to change around communications and data networks and that sort of thing. So thank you for the presentation today.
Oh, thank you for the opportunity.
And with that, I'm going to go ahead and conclude the presentation for today. I'd also like to thank everyone who attended. Thank you very much, and this ends the presentation for today.